Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with the monitor for the Merlin Tonto. And as you can see, I have actually managed to extract that PCB out of the actual monitor chassis. It wasn't particularly easy to do, and I must admit I didn't try and capture it on film because it was fiddly to do. Basically what I had to do is these are little plastic spacers that held the PCB onto the side of the chassis there. And just take a pair of pliers like them, and I thought I'd just be able to squeeze them in, pop the board off them mounts and slide it out, but I couldn't get it out. Even with it all popped off like that, I couldn't get it round the yoke there on the CRT. So what I ended up doing was actually then going onto the other side and actually popping them mounts out completely, and that did give me enough room to be able to slide the board out without actually having to disconnect anything. So everything's still connected up here. I just literally managed to get the board to slide out this way so we could access it. And straight away what I can see, I'll zoom you in on this. Oops. There we go. Let's get you in on here and down a little bit. There's two capacitors which are screaming out straight away. That could possibly be an issue, and that is, let me get my screwdriver to point with, that one there. If you look, if you look at these capacitors here, I know it's a smaller capacitor, but can you see how the plastic on it goes all the way over the top and kind of shrinks around it? Look how that's all shrunk back there. So I have a feeling that's been getting very hot. The other one, which I'm a bit suspect about, is this. It's only a small. I think it's a 4.7 at 6 volts there, and the whole top of it is blown up and domed up. I don't know if you can make that out on the video. So those two capacitors look rather suspect to me. So when you see something like that, I mean, it's the first easiest thing you can possibly do. Really, is let's replace them two capacitors and see if that makes any difference. The next thing I'll be moving on to is actually the next component in line, really, which is that. What we've got, I'll just tip you up so you can see what I'm pointing at a bit better. Oops, there we go. That there, that's the line output transistor, and I say if that shorts out, that could put a dead short onto the circuit as well. So because they look physically distressed, we'll change them first. If that doesn't make any difference and we've still got a short on the circuit, then we will possibly look at replacing that. Let's just make sure we've still got our short here. So we need a ground. What have we got that's definitely going to be ground? Well, probably a good ground is going to be that. Let's have a look on here. I should be able to figure it out from the connector that connects onto the top of here, because that'll have a ground on it. Ground is purple. Purple is at the end, so this end connection there is ground. So that's our ground connection there. We know that the orange wire, which is that's 1, 2, 3 along from that, is our 12 volts. So we know we've got. Let's switch on the meter again. Just make sure we've got our short there before we start. So I'll put this on the end, that's on ground there. And then maybe 1, 2, 3. Hang on, let's just double check that. Yeah. That's ground on there, and then that should be our 12 volt input. And yeah, there we've got our nice dead. Oh, hang on, you can't see that because I've got you all zoomed in on to let me zoom you out a bit. You have a look at the meter there. Now I'll connect this back up again. So we go from ground and onto the 12 volts. You can see there we've got a nice dead short there. So let's get you zoomed out. Let's start by we'll start with that big one there, I think. Let's get that capacitor out of there, and I've got some replacements here. Oops. I've got some capacitors over there to go in. So let's get the soldering iron. It's not always the easiest when you're working on something where it's all connected up like this. You've got to be very, very careful. You don't disturb too much. That's one of them. That's the other side of it. Just trying to get this. I'm trying to get this capacitor out. Well, it's definitely loose. There we go. Let's pick that up. Ooh. And that capacitor doesn't look too healthy when we look on the bottom of it. It's got a split around one of the legs on that side. Let's just try it, see if it's short. It definitely needs replacing, but let's see if this is our shorter component. Let's just stick the meter across it and have a look. Well, that doesn't look healthy at all. That's showing about 70 ohms. So that capacitor does seem to have turned into a resistor, so we're good having that out of there. I think we'll probably have a go at taking that the next one out at the same time, because it actually, with that one out of the way, it does leave a little bit more room around there, so it should make it a little bit easier to get this next capacitor out. Which way around are the legs? It'll be a bit of a pain to get out, but we'll get it. We're just heating up each pin at a time and slowly drawing it out. There we go, it's out. So that's the other one I wanted out of the way. Let's see which, that's negative there. Right. And again, let's just see if this is shorted or not. Because that first one we took out definitely isn't very well. Let's see about this one. Well, that's faring a little better, but I think we'll still replace it anyway, because it doesn't look so good the way it's domed up like that on the top. I mean, that was just a resistance reading I was doing on it. That's not like your be-all and end-all test of a capacitor, but at least you're seeing if it's shorted or not. As well, that one definitely, like I said, that's showing about 70 ohms, so that's definitely got a short on it. It's not to say that we haven't still got a fault. We still could have a shorted output transistor, but let's put this new capacitor in here. A little bit fiddly. Just bend the legs into position. On, in you go. I'm going to have to see if I can clean the pads up on this side. Can't get that to push through. I have found a little bit of solder braid, thankfully, so hopefully. In fact, I'm going to have to tilt this over and to make life a bit easier for myself. There we go, that's better. Now we can just use a little bit of solder braid just to remove the solder from where we've taken that component out. And I've actually just noticed, I don't know if you can spot this, I'll zoom you in a minute, but there's actually a component here which has never been soldered. let's find out where our capacitors just come from. Now, where have we just come out of? We've just come out of there. Just use a bit of solder braid just to take the excess solder away, so we can see the holes to put the new component in. There we go. We'll put this new capacitor in there, and then we'll do the 1000 UF one, and we'll see if that short's still there. If it is, we'll have to pull that line output transistor out and see where what's happening with that, because I think that's probably the next suspect. Let's put this capacitor in. There we go, that's in position. Just hold that with my finger. We can just bend the leg slightly to stop it coming out. That one that way a little bit. That one that way a little bit. We'll probably snap. We'll probably just trim that down once we've got that in place. Right, let's get that soldered in place. Let's just get you up here like that. Oops, there we go. We'll solder that new capacitor in place. There we go. Just trim that leg off. Right, that's that one changed. But this is what I was, I don't know if you're going to pick this out on the camera or not. Let me try and zoom you in as close as I can. I don't know if you're going to make this out or not. Let's see. See if I can point at it. Can you see that one there? There, that one. That's never been soldered. There's no, it's completely dry joint. There's no solder around that component leg at all, ever. So that obviously got missed in the factory. Let's rectify that straight away. There we go. That's now soldered to its position. You do come across that, especially in stuff like British built stuff from like the 70s and 80s, where yeah, it just never kind of ever got soldered. Right, let's put a new 1000 UF cap to replace that other faulty one. I've got a 1000 UF at 16 volts here, which is exactly the same as what came out. So let's stick that in there. There we go. That's in. Oops, that's not good. We've lifted a pad there. I don't know if you can see that. We've lifted a pad as we push that through. That's another thing. These boards are not good quality. Anyone that's worked on 1970s TV sets will be well aware that some of the old printed circuit boards used were not brilliant at all. Yeah, that's not good. It's lifted the track. We'll have to do a little bit of remedial repair work there. Just bend that leg over so the capacitor doesn't drop out. Let me spin this around so you can perhaps get a better look at it. Oops, let's not scratch my desk either. And I just knocked all the little things that I hold the PCB in all over the floor. Great. Right, now where is it? course now I've spun it round, I've lost the orientation, I can't see the bloody part I'm meant to be fitting. Where have you gone? Oh, there it is. Right, there it is. Well, it's not too bad, we have actually managed to get it through. Oh, let me get you down on it so you can see what the bloody hell I'm doing. Right. Right, we're here. Let's just solder this first one in position. Yeah, I ain't cleaned off. Let's solder this first one in position. There we go. And this one, it has just lifted the, it's basically lifted the pad ever so slightly. But, I think, there we go. That'll be okay. I say it's something you've got to be really careful of on these old phenolic boards. They're basically impregnated paper, resin impregnated paper boards, and you can lift tracks on them for fun. But we got away with it that time. That's no problem at all. So that's them two suspect capacitors. I mean, one seemed okay actually. It started charging, so it weren't short. The other one obviously did have a definite short on it because it was only showing. It was showing what, 70 ohms, which, you know, that's a resistor, not a capacitor. Right, let's see if we've still got that short on the. Let's see if we've still got that short on the input. Let's go from there to there. And our short has gone. Let me get you down on the. Oops, where is it? I'll zoom you out a little bit. There's the meter, so you can see that, can't you? Can you see the? You can see the display on there now. Like I said, we do the same thing. We go onto the ground, and we go onto the input, which is 12 volt input, which is there. Now, can you see how that's charging up now? That's it. Just basically just charging a capacitor. That's fine. Remember when we did that before? We just got a short across there. So, looks like that was our primary suspect there. Then it was that capacitor which had overheated. Right. Well, I suppose the next thing to do is get this thing reassembled. Let's get you to zoom back out. Out you come. Oops. You come out further than that. Oh, you'll have to do there. Right. So I think the next thing we'll have to do is get this board and everything mounted back in the bloody hell, mounted back in here, and I will pause you and come back to you once I've actually done that. Mainly because I seem to have dropped one of the little mountings here, and it's probably going to take me a good half an hour to find it on my office floor. So. We're back as soon as I've got this board actually mounted back in here, and we can take it a little further. We can actually see if this thing's perhaps going to power up. So we're back very, very shortly. Right, now as you can see, I've got it all back installed in here. It went in a little bit easier than I thought it would. But and this is Sod's Law. As soon as we get it back in here, our short's back. I'll just get my tester here and set that up. Can you make that out there? Let me just zoom that in a little bit. Oops, there you go. Yeah, you can see the dial there. And if I go across the between the ground and the 12 volts, as you can see, our dead short's back. So. That's weird because, I mean, like I said, that capacitor is definitely shorted. Like I said, it's showing about 70 ohms, so that's not right. And it's not showing anything else. That one, like I said, it was at least showing as a capacitor, so like I said, it was starting to charge up. So I think that was probably okay, it's just not in a very good state. But, what the weird thing is why has the short come back now? So I'll just pause you again and we'll get the board back out and we'll test again, and that's most odd. we'll have to have a bit of an inspection, see what we can find. So back in a minute as soon as I've got this board back out. Okay, I've managed to get the board out again. Unfortunately, I actually managed to do it with leaving the standoffs in position. We may have to pull them off anyway at a later date to actually get in and perhaps desolder something, but at least I managed to pinch them off and pull it out. I really don't want to have to try and take this board in and out, because eventually we'll end up breaking one of these standoffs, because I mean they are all plastic, and I haven't got any exactly like that, so we'd have to do a modification or something and make a different type of standoff, which obviously, you know, if I can preserve it as original as possible, that's what I really want to do. But anyway, we've got it out again, and get the old meter up there. As we can see, we go between the ground connection, which is that one, and we go between the 12 volts connection. There we go, our short's back. So that's really weird, because you definitely saw before that the short was gone. And so we just had a capacitor charging normally. So the only thing, my next port of call basically is to pull out that power transistor, and we'll have a look at that power transistor, and I'll just show you what we're talking about. It's this one here. It's the line output transistor which actually drives the line output transformer there. There's a good chance if that's gone short circuit, that could be causing us issues. I suppose what we should really do as well is check this capacitor, that capacitor there, and that capacitor there. Make sure that none of them are shorted. Because I mean, all it really needs is a short on the one of these capacitors, like a bypass DC coupling capacitor, a bypass capacitor, or something like that, and that could do it for us. We could even have a faulty IC there, although I think it's probably unlikely that. Let me get you up a little bit so you can see the board better. So let's we'll pull this out of the way because it's right where I'm going to be working. There we go, we've got that out. Basically they have a little, I don't know if you can see that, they have like a little, come on, focus, like a little tag on them there, can you see it? And what you do is if you press it in with a pair of pliers like that, just squeeze it in with a pair of pliers, you can then just pull these out. Far better than try to do it with your fingers and just twisting and what have you, because you could risk damaging it in that instance. Right, while we're in here, let's just quickly do a quick resistance check on these capacitors. Just ascertain that they're not actually shorted or anything. So, you know, basically, if it's a good capacitor, I've got a good capacitor here, and I'll show you what. Let's get you on the meter as well. You can see the meter there. You can see the board we're working on there, so that's all right. But like, so this is a good capacitor. I'll put that across the meter. Can you see it charging up there? And then it'll just go to open circuit like that. Now, a bad capacitor, generally speaking, will just this is that one that I pulled out. We connect that up. Actually, in fact, that's. And why was that? I mean, it is a bad capacitor, it's cracked, but that's actually showing. That's basically seems to be working now. That was showing 70 ohms last time I tried it. Oh well, never mind. Let's try some of these other caps and just see what we get. Right. We'll find out which side of these is negative and which is positive. Have been marked. These are 100 UF at 25 volts. That top's the negative. So the negative's the top there, and then obviously the positive's underneath. So let's just go across there. That's the other side of it. That's showing completely open circuit, that one. So it's either... Well, one thing, it's not definitely not shorted. Let's try this next one. So between there and there. Ah. Now we could have a shorted capacitor there. So it may be as well just to pop that one out and just test it out of circuit, because that was only showing a few ohms. Obviously, I mean, you test them with the capacitance tester really, but this is just a quick go no go test kind of thing. Let's try and get this one out. A bit of fresh solder to the iron. Let's try popping this out again. Okay, that's coming. There we go. That's the capacitor out. Put the iron down for a second. And we'll just test it out of circuit and see if it charges up. Then obviously we know there's nothing really wrong with it. If it's like that and it's showing a short circuit, then we know we've got an issue here. I mean, they're not usually too bad, these. The Philips branded ones, 100 UF at 25 volts. Now that's not showing anything on the resistance tester. I've got my component analyzer here. It's only a cheapy Chinese thing, but it does work quite well for stuff like this. Let's just quickly get you down on the display, and we'll see what this capacitor actually shows up as. Right, so it's not good. It's 100 UF cap and it's showing out at 62 UF, so I think it's well worth changing. But it's not going to be, it's showing as a capacitor, it's not showing as a resistor or anything, so it's not going to be the issue that we was having. We might as well pull the other one out there. In fact, how many other caps, how many other electrolytic caps haven't we changed on this board yet? We've got one there. Let's have a quick look. Yeah, we've got one there. We've already changed that. We've already changed that little 4-point. Oh my god, you can't see what I'm pointing at there, can you? So we've got one there. We've already changed that out. We've already changed that little 4.7 UF out that's in there. We've got one there, one there, one there, and the one we've just taken out there. Now, like I said, that should be 100 UF and it's showing up at 60 odd UF, so that's... I've not tried a ESR or anything, but I don't think that's in a particularly good order. So what I think I'll do is I'll have a quick squiz around this board. I'll find out what all the values are, and I'll go and have a hunt and just see if I've got some better capacitors to throw in this thing. I do desperately need to get some more electrolytic capacitors. I must admit I'm quite low on a few values, but I've got some ones that I can, some modern ones that I can salvage off a good board that we can at least throw in here for now, and see whether that's actually going to get us any further further on. I don't think I won't bother filming me changing all these capacitors, because you've seen me change lots of capacitors in the past. So I'll come back to this as soon as I've swapped out these capacitors, and I'll start the camera back up if I spot anything interesting and we actually find a bad one or something like that. So back very shortly. Okay, well, as we can see, I've replaced these 3 capacitors there, which were these. Those, oops, where are you? Those 3 there. They're all, the originals were 100 UF at 25 volt, they've no temperature rating on them. And I've replaced them with 100 UF at 35 volts, but these are 105 degree, and they're Rubicon caps, so they're not a bad one. I pulled, there's a 10 UF capacitor down here that I'm pointing to. It's a 10 UF at 100 volts, and I didn't have any 10 UF 100 volt rated caps I could find. But I did pull it off the board and test it, and it tests absolutely fine. It's 10 UF, there's no leakage on it, so we're happy with that one. Again, this one up here, that's the 68 UF at 16 volts. I haven't got any. I just did lift one side of it and then give it a quick test, and there's no leakage in it, but the value's quite well off. It's showing about 49 UF, so it's well down. I will find a replacement for that, and I will replace that one. I'll probably replace that other Philips, that 100 volt 10 UF one actually, but like I say, at the moment it is showing okay. Unfortunately, none of them were shorted. None of the caps I've just pulled off were shorted. I mean, they were bad on value, but that's not really a major issue. So if we look, I mean, we've still got our short, unfortunately. So I think the next thing we're going to do, I mean, we could look at some of these larger caps, but these really don't fail. Very rare have I ever known of these to fail. There is an older one though. This is a 0.01 UF at 1500 volts that we could possibly have a look at. But I think my first port of call, honestly, is going to be a line output transistor there. I have a feeling that if it isn't any of them electrolytic capacitors, then it's a possibility it's going to be that line output transistor which has failed. Now, we will whip that off the board, and we can test it on the component analyzer. I mean, basically what I'm doing here, I'm going through most likely. Basically it's a small monitor, they run warm, these things, so the first thing that's most likely to suffer in that instance is an electrolytic capacitor, because it's got a wet electrolyte inside it, which obviously heat over time is going to dry out and the capacitors are going to start malfunctioning. After that, really, just through messing with old solid state TVs and old monitors in the past, one of the other most common faults is the line output transistor, because it's driven heavy, it's driven hard, and basically they don't last forever and they do fail, and sometimes they can fail short and literally do something like this. My biggest concern is it never took the fuse out with it. But anyway, let's pull the line output transistor out. And what we will have to do is observe any insulation which is being used on this thing. In fact, what we'll do first is we'll just ascertain whether the top of the transistor is actually connected to the heatsink or whether it's actually isolated from the heatsink. Because if it's isolated and we don't put the isolation back, rather bad things can happen. So let's set that to a resistance range, and okay, so we go on. Let's go on the back of this bolt, which is basically on the tab of the transistor, and then to the heatsink. Now there's quite a high resistance there actually. Let's see if we can see the meter. Let me whack you down a little bit. So we go there, as we can see, we've got no resistance, but if we go between that tab and the actual heatsink, there is. So what we don't want to do is we've got to make sure that when we put this all back together, that we make sure that the tab of the transistor is actually electrically isolated from that heatsink. If we don't do that, all nasty things will happen when we power this thing back up. So let's get this transistor out of here. It could be one of the supporting transistors that's failed. We could still have an issue with one of the supporting transistors, basically one of the transistors that actually drives this big switching transistor. We'll take off them. And there's an insulating sheet behind this transistor to isolate it away from the heatsink. It's a piece of mica. We'll just very, very gently take that out of the way, because hopefully we will be able to reuse that. I do have some replacements if we can't, but take that piece of mica out, and we should be able to now desolder this transistor. Right there. And again, we'll just try and heat a couple of legs up at once and see if we can just rock it out of the board. That's the first one. Pull it that way a little bit. Heat that one up. Pull it that way. That way. Oops, that's broke free there. I think this transistor was actually getting very, very hot because the solder's in a shocking state around it. Right, that's free from solder. We should be able to pull that out from the other side of the board. But solder was in a very bad way around that. It must have been very badly heat damaged, because it just crumbled as I applied the soldering into it then. Right, let's give this a... Why are you not pulling out? That's free there. It's just got one little bit of solder holding that. Let me just... I'll hold it with the pliers like that, and we'll grab it with the soldering iron. We should just be able to pull that last pin out. Just hold it like that. Let me grab the iron again. Oops. There we go, got him. Right, let's have a look at this. So there we go, that's the, it's a BU805, that's a fairly standard big power transistor. I'm pretty certain I've got some of them. Well, let's give it a quick test on the, we will give it a quick test on this component analyzer and see what this makes of it. I mean, we don't need to use this. We could use a multi-tester to test this thing. It's easy enough to test a transistor, but seeing we've got this, it'll tell us what it is. Well, if it's working anyway. Connect up the power transistor like that. Press the button, and it should tell us what it is. Right, that's actually fine. That's not shorted at all. There's nothing wrong with that. Let's see if our short's still there or not. Problem is, you've got to get the board in a position as well where let me zoom you. Oops, wrong way. Let me zoom you back up again. So like I said, we've pulled the power transistor off, and it wasn't that. That's not the issue. This is definitely becoming a bit of a weird one. let's get the meter out and let's just make sure our short's still there. I don't know where I can put that where you can see it. I think you can see that there. Yep, our short's still there. So we're literally ruling out everything, one thing at a time with this. We know that it's not electrolytic capacitor related now. We know it's not the switching transistor which is the issue now. So that really leaves one of these ICs. There's only two ICs on the board which could be shorted. It could be one of these two driver transistors here, which actually they're basically the driver transistors which drive that line output transistor. We could potentially have a short in one of them, or we could have something wrong with one of these orange dip capacitors, or one of these two capacitors here. But oh, and there's another transistor there which I hadn't spotted, which is probably for something like horizontal deflection or something like that. Again, we could potentially have an issue with that there. But that really is it. And one thing I have just thought actually, could we have a fault on the board, on the net board for the CRT, because that's got an electrolytic capacitor I've just spotted on it as well. So we could possibly have a go at pulling that. That's going to be an absolute pain to get out, I think, because of where that IEC connector is down there. I'd have to take the IEC. Oh, that's not, it's too bad. I'll have to take the IEC connector out, and that should help allow me to release the board off the back of the CRT neck there, and we can just have a look at the electrolytic capacitor that's on there. But apart from yeah, apart from that, this is being a bit of a stumper. The really horrible thing, no, actually no, I don't think that could cause an issue. I was going to say a shorted winding in the line output transistor, but that's really isolated from the mains input, because like I said, you use a power transistor to actually switch that to create the high frequency pulses to drive that. So it'd be the transistor which would be at fault. I could see a short in that blowing an output transistor, but I can't see a short in that, you know, shorting out everything and not damaging the output transistor like the issue is that we've got is. This is definitely an interesting one. I think what I'll do is I will reinstate the line output transistor there, and we'll try pulling that other transistor there, and then I'm going for the power transistors first, because that's another power transistor down there, purely because they're more likely, you've got probably more likelihood of them actually failing. Then we've got them two driver transistors there. I suppose they're the next things to try. This is it would be so much easier to do this, I must admit, if I had a schematic diagram for the monitor, but I don't. I've searched and searched, and I can't find any data on this monitor at all. So I'm doing it blind, really. We are going back to basics with just trying to locate what is short circuited on it, really. Anyway, what I will do, I'll pause you now while I just get this transistor whizzed back in there, and we'll pull out that other transistor there. We'll give that a quick check, and we will take it from there. We'll probably do them two transistors next after that. Right, so back in a second. Okay, well that's the line output transistor reinstalled there. I have pulled that transistor there and tested that. That worked out fine. Again, and I've pulled out these two, which I believe are the driver transistors which drive that line output transistor, just looking at how the circuit seems to be wired on the back there. I've pulled them out, and let's give them a quick test and see see whether they're the issue. And if they're not the issue, then literally, like I say, we've eliminated all the wet electrolytics on this board, and we'll have eliminated all the transistors on the board. So that just leaves the other foil capacitors and the two ICs, really, that can be causing the issue. But anyway, let's get onto the transistors first. Now let's see what we got here. Now this one here, that's the transistor. It is a, I can actually read this one. This is a BC635, I think, which was the transistor closest to the power transistor there. It's marked up as V25. So let's have a let's test this and see whether this is working or not. We'll just get you down on the old tester. And that seems fine. That's showing as a PNP transistor, and yeah, there's nothing wrong with that. And that is the one that goes in first. Let's put that ready to go back in, and we'll try this one. This one I'm struggling actually to make the part number out on it. I think it's a C548. I'm presuming maybe an NPN transistor, because a lot of the push-pull, sometimes you'll see an NPN and a PNP used together. Let's see anyway. Let's connect that up. Now this doesn't prove to be faulty. Like I said, we're really down to them other capacitors. And that's an NPN, yeah, and that's fine. So this is the tricky one, basically. Like I said, we've all the parts that I would consider to be the most likely to be at fault. We've checked, and they seem fine. Yeah. Yet we still have the short. I think the next thing we're going to have to do is, unfortunately, you really don't see these faulted, but I can't think of anything else. We're going to have to go through all these. I'll get you up on the board again. We'll have to go through all these orange tips, because we've ascertained that it's not an issue with the other thing is to pull these off. They're going to be a pain in the backside to do. So I think that's going to be on the next video anyway. This is turning out to be quite a long repair, isn't it? So yeah, we've ascertained that our wet electrolytics are all fine. We've replaced any which were out of tolerance, and the other ones that are out of tolerance, we've actually at least checked that they're not shorted or anything, and they're okay for now. We've pulled out all the semiconductors, well, apart from the diodes. We've pulled out all the transistors. We've tested them. We know they're okay. So, I mean, I suppose there's a few diodes on here. I think they're like fast switching diodes. There's one there. I think I spotted another one about somewhere. The diode there. Can I see any more? No. Yeah, there's another one. Oh, there's another two in there. We'll have to test them, make sure that they aren't short circuit. But we're running out of things really to to check out on this thing. Anyway, I'm going to leave it there for now, because this video has already dragged on far too long. I think in the next video we'll look at the rest of the components that could possibly be on this. Honestly, if I had a thermal imaging camera, I'd seriously considering hooking this thing up to like a stabilised DC supply, feeding it like say 12 volts at 1 amp into the thing, and basically looking at it with a thermal camera and see what's getting hot. Unfortunately, I don't have a thermal camera, so that idea is out of the question, but that would be a nice, quick, easy way to possibly locate whichever particular component's getting hot. We could do the poor man's version of that, which is basically, we hook it up to a constant current power supply, so it can't pull more than what we decide on it, say an amp. We put like 12 volts and an amp in it, and then we start wiping over the board and over the components with basically a Q-tip with isopropyl on it. And if we see, as we go over it, suddenly we find a component and the isopropyl evaporates immediately off it, we know that component's getting hot. And that's another way of us localising the fault. But we'll go into that in the next video. Like I said, I'm going to leave it there now because this video's dragged on far too long now. So I will say until the next video, thanks for watching and goodbye.